All right, we're here with our Period 2 Honor Stats class, and we're starting our new unit on probability. So the first thing we need to go over is to talk about what probability is. All right, so we actually just had a chance to go through, even without using all these vocab words, we had that activity about the random babies allowed us to kind of experience a lot of this stuff, especially the trials. All right, each of you got to do 5 trials, and then together, when we pooled our data, we had a chance to see what it looked like if we had run 90 trials. All right, and we recorded outcomes, and ultimately, we wanted to try to find the likelihood that Mrs. Johnson would get her baby Jerry, and the likelihood that all 4 mothers would get the wrong baby. And for me and my data, I ended up with 23% and 36% for those 2 events. Yes, Daisy. Oh, okay, fine. Leave your phone, take the pass. Yeah. Matched pairs is when they have somehow looking at 2 people at a time.
Oh, no way! I actually made that.
What do you do?
What's the probability?
Right now, 1 trial, 1 success, 100%. All right, now, here is one of my biggest pet peeves in statistics. All right, and it happens pretty much, I'd say almost half the time I'm watching a basketball or football or sporting event. Okay? So the thing you need to know is called the law of large numbers. That in the long run, a probability is the likelihood that that event occurs with infinite trials. Now, there's no way we can do infinite trials. Okay? We're talking about large numbers. So lots of trials, millions of trials. Okay? So the biggest pet peeve I have is when people start talking about something called the law of averages. All right? And the law of averages is not a thing. I don't even know where it came from that people call it a law. It's not a thing. It's not a real thing. It's not a law. It's not real. It is so fake. Okay? And I hear it all the time when I'm watching basketball, where it'll be like, oh, this team only shot 30% from the floor. So because over the season, they've shot 50% from the floor, they're going to shoot much better in the second half. It's got to average out. That's not how it works. Okay? That is someone trying to understand the law of large numbers, but failing miserably. Okay? So if you start hearing somebody talk about the law of averages, okay? Yes, pause, or if you can pause, all right? And make a phone call or write your senator. All right, one of those 2 things. All right? Is that a thing? People write your congressperson? Yeah, there you go.
President Trump didn't respond to me.
Okay, well. The mayor, there you go. Which we are not sure who the mayor is yet, right? Did they? It's a runoff. Woo! All right. Okay. Now, let's go ahead and talk a little bit about some important things about probability, which you guys already know from middle school, but I'm making it a little bit more formal since we're in high school now, in really college with this material. So there's a couple of requirements for probability. First off, your probability has to be between 0 and 1. So if somebody says the probability of this happening is 130%, that cannot be correct. It has to be between 0 and 1, or 0% and 100%. Okay? That also means that if you're looking at the likelihood of all your different events occurring in your one sample space, that they all have to add to 100% or 1. So if you're adding percentages together for all the different likelihoods of something happening, and they all add up to something that's more or less than 100%, something's wrong. Maybe you wrote down a number wrong, or you're missing one. Something is incorrect. Okay? Okay. Now, no, you can use probabilities as decimals or percents. I don't care. The way statisticians do it, Catherine, is when they're doing calculations right? When they're doing all their math, they use decimals. When they write sentences, they use percentages. All right, so that's what I'm going to do. All right, now, the next couple of things, this complement rule means that if I say the likelihood that Saul makes that shot is 5%, then the likelihood that Saul does not make that shot is 95%. All right, so 100% minus or 1 minus, that is called the complement. All right, you'll see that happen often. Okay, there's a couple rules we're going to use for this chapter, and these are the simple ones, so hopefully you'll feel confident as we practice these on Thursday. This addition rule says that if you want to find the probability of event A happening or event B happening, you just add the probabilities together. Now, there's a big rule here that they're assuming. There's a big assumption that they're making. It's assuming that these events are disjoint or mutually exclusive. And that's a fancy term. You start throwing those words around, you know you're in college. Okay? Now let me try to explain what disjoint and mutually exclusive mean. They're the same thing. Okay? You can use either or, I don't care. Okay. What's the likelihood that you're going to get an A in this class?
0.
Wow, we're still not done yet, right? So no one's chances are 0. Now, let's say right now you're sitting in my class and you've got a 94 for quarter 2. You have a 97 in quarter 1. What's that person's likelihood of getting an A in my class? High. Not 100, but high. Probably somewhere above 80%. Okay? What if somebody's sitting in this class, quarter 1, they got a 72, quarter 2, they've got a 75. What's their likelihood of getting an A? Lower. Still a chance, but lower. Okay? Now, it's December. Okay? It's December. You've taken your final, I've graded it, and I've told you, Saul, you got an A. Now, what's his likelihood of getting a C? 0. I just told him he got what? Hold on! I just told him that he has what? He has an A. So his likelihood of having a C now has gone to 0. Because you can't get both. Now I'm talking about the whole grade. Semester grade. Okay? So your grade in a class, those are disjoint events. The likelihood of you getting an A, a B, a C, or an F are disjoint events. Because once one happens, the other can't. Although they're all watching Bianca move this desk. You got it, Bianca?
Where does it go?
What number is it? Right there in front of Wences. Thank you so much. I'm going to say that again because we're all watching Bianca. Let's try again. The likelihood of you getting an A, B, C, or an F in any class, those are called disjoint events. Because once you get one of them, whether it's an A, B, C, or F, you can't get another one. All right? So disjoint means that when one happens, the other can't happen. Those are disjoint events. Okay? That's another way of saying mutually exclusive. When one happens, the other cannot. Okay? Okay.
College admissions.
Now,
Going to go to this college are 9.
the last slide talks about another rule, the multiplication rule.
I have a question. Do we have
Yes.
to write-
No, but you'll use them so often that you'll just know it. Now, this one says the probability of A and B happening. So both things happening, both events happening. You multiply their probabilities. But again, this is a massive assumption we're making that these events are independent. All right, so let me try my best to explain independent events. Okay? Now, in words, independence means that if one event happens, the likelihood of the other event is unchanged. So it's unaffected by that first event happening. Here's my favorite example. Okay? My favorite example. We just had Veterans Day, right? We just had Veterans Day. All right? What's the likelihood that the parade for Veterans Day happens in Houston? Not 100%. Can't be 100%, right? What if an asteroid hits? Can't be 100%. I'm saying Veterans Day happened. Let's say this Saturday is a parade. Okay? My bad. What's the likelihood that this Saturday the parade happens? High, right? High. Very likely, unless some weather event or something happens, right? High. High.
I think
It's high.
no, because it already happened.
Okay, well, I'm trying to use an example, Catherine.
Parade.
So if you go to the police station.
Just give me a second.
If you go to the.
Now, you're going to miss the whole point of this. You're going to miss the whole point of this. Now, so the likelihood of that parade happening on Saturday is very likely. Now, what is the likelihood that it rains in Germany on Saturday? I don't know. 50%, 20%, 80%, who knows? All right. Now, what if I tell you Saturday morning we wake up, hey guys, it's raining in Germany. It's raining in Germany. What's the likelihood that our Veterans Day parade happens? The same, because it's unaffected by raining in Germany. So those events, rain happening in Germany on Saturday, parade happening in Houston on Saturday, are independent events. Why are you clapping so much? Yes, Lily J. Yeah, so you can use these signs. That's union, all right, for or, and then this one is and. It's the same. I don't care. I prefer words, but you can use symbols too.